Hello everyone, my name is Neha Agarwal and I'm a tech lead here at Velotio. Today I'll be presenting a topic which is very important where we'll discuss the best security practices available for Android applications. So let's talk about why exactly security matters. As we all know, technology has become increasingly integrated into our lives and the importance of robust security cannot be overstated. Android apps sort of serve as a gateways to our personal information from financial data to communication, and these are basically prime targets for malicious activities. If you look at the landscape of security threats, mobile apps face a diverse array of those. They range from data breaches and unauthorized access to very sophisticated malware attacks. And the ever evolving nature of these threats necessitates a proactive approach to ensure the integrity and confidentiality of user data. Users entrust their personal information to various mobile applications and they expect a secure environment. Establishing and maintaining user trust is contingent on the app's commitment to implement and communicate robust security practices. The purpose of this presentation is essentially to provide insights into the best practices for securing Android applications. And by understanding and implementing these measures, developers can fortify their apps against potential threats, ultimately enhancing user trust and satisfaction. So now basically in this presentation, we are going to focus on three key areas to mobile security: data storage and privacy, authentication and authorization, and the last is network communication. So going to the data storage and privacy, as you can understand, it is very important to protect stored data and it is critical to prevent unauthorized access and maintain user privacy. Sensitive information such as user credentials, personal details, financial data, these must be secured. Now, the best practices is to implement a strong encryption for such data, right? There are various tools to do that, which we are going to discuss forward. There are some challenges to it as well, like balancing performance and security, as encryption can introduce processing overhead as well, and ensuring the secure key management to avoid exposing encryption keys. Now, these are the three methods that we'll be discussing for data security. First one is the Android key store, which provides a hardware-backed secure storage for encryption keys, ensures keys are protected from unauthorized access. The second one will be encrypted file API. Here, it makes sure that all the files are encrypted, and this method is basically ideal for storing sensitive documents or data locally. And the last is SQLite encryption, which is encryption for the database to protect stored data. This is commonly used for apps that require a local database. Now, the first one is the Android Key Store. Android Key Store is the basic one, which is a hardware-backed security module that provides a secure storage environment for a variety of purposes, like for storing encrypting keys, doing cryptographic operations, and basically key management for securing data. As you can understand, the benefits of it is this is a hardware-backed security system where where the protection against key extraction is seamless and it integrates with the Android security infrastructure as well. This is the preferred choice for managing encrypting keys in Android apps and provides a high level of security, which is essential for securing sensitive data. We'll take a look at one of the examples where we are using the Android key store to store encryption keys. Now, as you can see over here, the first part where we are doing key store initialization. This initializes Android key store to securely store cryptographic keys. The next part, we use the key generator to generate a symmetric key. Let's say for an algorithm such as AES, we give the specifications for the keys, what sort of unique alias we want to use in it, the purpose, whether it is to encrypt or decrypt, use a GCM block mode, and other optional things such as user authentication. This ensures that the generated symmetric key is securely stored within the Android key store system. This is a versatile encryption system. The generated key can be used for secure encryption as well as decryption operations in the applications. The next part is the encrypted file API. So as we talked about, this basically allows you to create, read, and write encrypted files on the Android device. It encrypts data at the file level, making the file secure at rest. Whenever we want to store some sensitive documents, user-generated content or files that need to be protected, this is the way to go. The benefits you get from this is it protects your file from unauthorized access, even when they are stored on the device, and it is easy to implement for file-level encryption. This is a useful method for securing files that need protection, such as documents, images, or any data that should remain confidential. So here we are using the encrypted file API, which is being used to create and work with encrypted files. Here, first of all, we are initializing a file, which we're specifying the file name and creating a file object in the app's private directory for strong encrypted data. Next part is the cipher initialization, where we obtain a cipher object configured for encryption using a function not detailed in the snippet. Then we set up a file output stream where we will write and wrap it with a cipher output stream. This is to ensure that the data is encrypted before being written to the file. And next, we write the encrypted form of the string. This is my secret data to the file. Now, at the end, we close this stream, and this is how we ensure proper flushing of data and releasing of resources is done, including the underlying file output stream. And the last section for securely storing data is the SQLite encryption. Now, SQLite is a widely used database engine in Android apps, and SQLite encryption involves encrypting the entire database to protect stored data. Whenever you want to store, a large data in a local database, SQLite encryption is basically will help you to protect that data. It is suitable for apps with substantial data storage needs. And when sensitive data is stored in a local database, encrypting the entire SQLite database ensures that the data remains confidential. So again, here is a simple example for SQLite database encryption, where we are initializing a database called my secret password using the open or create database method. And then we are creating a table using the SQLite command. Now, next, we're going to talk about authentication and authorization. Now, these are two crucial security processes in app development. They work together to ensure secure access to resources. Authentication is the process of verifying the identity of users. It confirms if users who they claim to be. The common methods will include passwords, biometrics, and tokens. Whereas authorization is controlling the access. This determines what authenticated users are allowed to do within the app. It defines user roles and permissions, and it is the gatekeeper to sensitive data and functionality. Now, some of the best practices for authentications are MFA, where by implementing MFA, we are adding an extra layer of security. This combines something that user knows with something they have. The second one is OAuth and OpenID Connect, where we use OAuth for secure third-party authentication, and OpenID Connect enhances OAuth with identity information. The last one is biometric authentication, where we are leveraging the various biometric methods to add security as well as user convenience. So first of all, we'll talk about the MFA. Multi-factor authentication is often referred to as a two-factor authentication as well. This adds an extra layer of security to the authentication process. It requires users to provide two or more separate authentication factors before granting the access. These factors typically fall into one of these categories: something that user knows, for example, a password or a PIN; something the user has, for example, a mobile device or a smart card; and the last, the something the user is, the biometric data like fingerprints or facial recognition. It is important significantly because it enhances security by reducing the risk of unauthorized access. And even if a password is compromised, it adds a crucial layer of defense against various threats, including password breaches and phishing attacks. So here we are looking at an example of MFA, where time-based one-time password, TOTP, is utilized. This example utilizes a TOTP implementation, a form of multi-factor authentication for generating time-sensitive codes based on a secret key. Now, the user is authenticated. It validates user-provided TOTP against the generated code, allowing secure access only. And if the entered code is valid, then only the user gets the access with the specified time window. The second method is OAuth and OpenID Connect. What it is? This is basically this is a widely adopted industry standard for secure third-party authentication. This allows apps to access user data from the source server, while OIDC adds an identity layer on top of OAuth, providing information about the user. It is very important as it enables users to grant limited access to their data to third-party apps without sharing their credentials. This minimizes the risk of exposing sensitive login information and allows for secure integration with external services. Here we again see an example where we are configuring an authentication provider specifically using Google Sign-in through the auth UI.idpconfig.Google Builder. This initiates a user authentication flow by creating a sign-in intent with these specified authentication providers. And the last one is the biometric authentication. As we all know, we have various biometric methods, behavioral characteristics of the user, such as fingerprints, facial recognition, or voice recognition to verify their identity. It is important as it is a highly secure and user-friendly as well. It adds an additional layer of security and offers a convenient and seamless user experience, reducing the reliance on traditional passwords. So here is a small example of biometric authentication where First of all, we are configuring the appearance of the biometric prompts, such as the title, what should be the negative button text. Then we initialize that prompt, and then it basically asks for user authentication trigger. We'll talk about the importance of network security. Network security is critical for protecting data in transit and preventing unauthorized access to your app's communication. Mobile apps often interact with external servers and services, making network security a vital aspect of overall. Common threats for network security are man in the middle, data interception, unauthorized access, data tampering. We basically can use HTTPS for communication, which ensures that all communications between your app and server are encrypted using HTTPS. We can implement a certificate pinning. We pin our server's SSL certificate to ensure only valid certificates are accepted, and the secure API endpoints. With regards to HTTPS, it is a secure version of HTTP, the protocol used for transmitting data between a user's web browser and a website server. It adds a layer of security by encrypting the data exchanged between the client, example, your Android app, and the server. Data encryption, it provides data encryption. All data transmitted between the client and the server is encrypted, making it unreadable to unauthorized parties. It provides data integrity, which ensures that data remains unchanged during the transmission. If any data is transferred with, the recipient can detect it. And it verifies the identity of the server, ensuring that the client connects to the correct and trusted server. Here is a small example. To use HTTPS in Android apps, we typically don't have to handle the encryption and decryption process directly. Android's network libraries such as OKHTTP, they provide and they make it relatively easy to incorporate HTTPS into your app. And now the certificate pinning, which involves hard coding the server's public key or its certificate in your Android app. When the app connects to the server, it checks that the server certificate matches the pinned certificate. If they match, the connection is considered secure. And if they don't match, the connection is terminated, preventing potential security threats. Here is this example where we first are implementing the certificate pinning by creating a configuration for enhanced security. We use a certificate pinner.builder to associate the server's hostname with a specific pinned certificate hash. Then we set up an HTTPS request using the OKHTTP client. Here, the configured certificate pinner is used to ensure that the server certificate matches the pinned one, providing protection against potential man-in-the-middle attacks. And then we execute the HTTPS request to the specified API endpoint, which checks the response success status and processes the response. Now, concluding this presentation, developers must proactively address security concerns rather than reacting and responding to the incidents. And as we all know, security is a very dynamic field, and staying updated on evolving threats and best practices is essential. Basically, by prioritizing security at every stage of development, we can collectively contribute to a safer and more reliable app ecosystem. Thank you for joining us on this journey towards building and secure Android apps.